Hello and welcome. I'm Matthew Lay, and in this lesson we're going to study voltage. Let's get started. We have some objectives for this lesson. First, we want to be able to define voltage. Next, we want to differentiate between voltage and current, what we had studied in the previous lesson. And we want to list the terms and symbols associated with this new concept called voltage. Okay, so here we have a 9-volt battery, and we're used to calling it that. And when we say 9 volts, what does that mean? I'd like you to pause the video, maybe even write down on a piece of paper what you think 9 volts means when we talk about a 9-volt battery. Go ahead and pause, and then come back, and we'll get into the study of voltage here. Okay, when we talk about voltage, we can view a battery much like a tank that's filled with liquid. So I have a water tank here filled with a certain amount of water. And down at the bottom here, I have a pressure gauge. And the tank containing liquid has some sort of built-up pressure or potential energy. We can do something with that. Water towers in municipalities have the water in a tank way up in the air, and they do that on purpose because it's pressurized due to gravity, and when they open a valve, it's going to distribute that water throughout the township. So that potential energy can be used as long as we give it some sort of path to flow. And of course, the amount of energy is going to be determined by the level in this tank. So if this level was all the way here at the top of the tank, I would have more pressure here at the bottom than I currently have. It looks like it's maybe a little bit over half. And of course, if I'm down here at the bottom, I'm going to have very little pressure at all. So let's take this concept back to our 9-volt battery. So this battery is like a tank of electrical energy. So it's not filled with liquid, but it's filled with electric charge. And this tank contains a certain amount of what we can think of conceptually as electrical pressure, which is potential energy as well. And that can be used, this battery can use that electrical pressure, the voltage, if it's given an electrical path for flow. And of course, the amount of potential energy is determined by the level of charge that's in the battery. So if your car battery is dead, what do you get out? You get out the charger, or you might get out some jumper cables to take the potential energy of one battery and transfer it into the battery that's dead. We are charging up, we're filling up that tank again with some potential energy that we can use. So voltage is required for electrical current. We can't have current without voltage. Okay, we can have voltage without current. We're going to see that here in a minute. So this 125 volt bulb is in a completed circuit. I can tell that because it has current flowing through it, and I know that because the filament is literally glowing. And the only way that's going to glow is if it has electrical current flowing through it. Voltage can exist without current. If we remove this bulb and our light switch was still on, we would have 120 volts present. We would have potential energy at that socket. There is no current flowing because there's no device for the current to flow through. There's no path, but voltage would still exist. So a 9-volt battery will have 9 volts of potential energy even when it is not an electrical circuit. So if you buy a brand new battery, you could take a voltmeter, that is a meter that can measure voltage, and put it across the two connections on top of the battery, and you'll measure 9 volts even though there is basically no current coming out of the battery. Technically, there's a little bit of current that goes through the meter when you take the reading, but it is so low we consider it no current. So who can we thank for this concept of voltage and for the invention of the battery? Well, it's this Italian scientist, Alessandro Volta. Um, he was an Italian physicist in the late 1700s, and he is known as the father of the battery. We can thank him. He invented the voltaic pile, which you can see here to the left. The voltaic pile was a construction of layers of dissimilar metals separated by some sort of electrolyte. Now, in the original one, it was copper and zinc. But we're going to talk about this later. Copper is an excellent conductor, but the best conductor is actually silver. So he did experiment with silver and zinc as well. But it was separated by either cloth soaked in salt water or cardboard soaked in salt water. In this particular example that we see to the left here, that's actually pieces of leather that have been soaked in salt water. That's a picture from the Smithsonian Institute. That's where the original voltaic pile exists and is in exhibit. But the electrolytes separated between those two, you can build up a specific charge. And then that is the potential energy that we have in batteries, and we can then use that in electrical circuits. The result of him building this voltaic pile was the first battery. Because of his work and his invention of creating this battery, the System International unit, remember System International is, we just simply call that the metric system. The measurement for voltage is going to be the volt, and that's where we get that. It was named in his honor. So voltage is the amount of potential difference in charge between 2 points. So when you go to the positive and the negative terminal of a battery and you measure specific voltage. So if we go to your car battery, it's going to be a 12-volt battery. What we're measuring is the difference between those two terminals is 12 volts of electrical pressure or potential energy. So it's a potential difference between those two. The potential difference between the terminals of a 9-volt battery will be 9 volts. Voltage can be termed electromotive force because it is the force behind our electrical flow, and it can also be thought of as electric pressure. When we use or quantify voltage in a mathematical formula, we use the letter E. Okay, we can't use the letter V because that's the letter for the units that we're going to see here in just a moment. But E comes from electromotive force. So that helps me remember that, electromotive force, or EMF. E stands for electromotive force or voltage in math equations. And voltage is measured in volts, and we're going to use the letter V for the units. Okay, so E is the quantity, and V is the units. The way they determined what 1 volt was for the System International units is it takes exactly 1 volt of electrical pressure to push 1 amp or ampere of electrical current through 1 ohm of electrical resistance. Now I know I'm talking about electrical resistance and using the term ohm before we've studied that, but we shall study that next. So the formula is 1 volt equals 1 amp times 1 ohm. The omega symbol, the little upside down horseshoe symbol there, is called the omega symbol in the Greek letter system, and we use that for to denote ohms. So that formula, if we use all of the letters, E equals I times R, E for electromotive force or voltage, I, remember for intensity of the current, I for intensity, and then R we're going to learn next is for resistance. So there are our three different quantities in that equation: electromotive force, current in amps, and resistance in ohms. So let's review. Define voltage. As we've begun a practice of, let's go ahead and pause the video, try to define it on your own, and then come back. Okay, voltage is the amount of potential difference in charge between 2 points in an electrical circuit. Okay, it's potential energy. You can think of it as electrical pressure, and it is required for us to have current. We have to have voltage to have current. What is the difference between a voltage and current? Okay, go ahead and pause and come back and we'll see the answer. Voltage is electrical pressure, and it is required to produce electrical current in a complete circuit. Okay, you can have voltage present outside of an electric circuit. It is just the potential that's there, much like you can have pressure in a tank, even though the tank isn't distributing the water through pipes or anything. You still have that potential there, but you can't measure flow through the pipe from the tank if a valve is closed. We can't measure flow out of a battery unless it has a completed circuit. List the terms and symbols associated with voltage. Again, go ahead and pause and then come back for the answer. E is the amount of electromotive force in math equations. V is the units that we use to measure electromotive force or voltage. So voltage and volts are different. Voltage is a quantity, it's a number. Volts is a unit. Okay? Some people get that confused. So try to grasp those two concepts. This concludes the lesson on voltage. I hope that was helpful, and we'll see you in the next lesson.